Hi everyone. I just want to use this additional video to talk something about an additional case study, which is on the geometric progression of housing price. So, what is a geometric progression? So, geometric progression talks about the progression of a geometric sequence or geometric series. So the geometric series is very common in our daily life. For example, in this case, we're going to analyze the housing price. So housing price is a geometric series because it increases in value proportionately every year, right? So for example, if I have a house which is 1 million, right, and it increases in value in by 5% every year. So this is year 0, year 1, year 2. Then it increases, for example, by 5% per year. So first year is going to be 1 million times 1 plus 5%. Second year is going to be 1 million times 1 plus 5% square, right? So, etc. And it's going to follow a progression, a curve, something like this. Right? So if you show it on the graph. Now the question is, since the price are increasing, and the question is, we want to ask ourselves is, can we afford to buy a house? And if we do, then how long does it take to buy a house, right? So, of course, each of us, when we graduate, will earn a salary. So this is housing price is our salary. So salary-wise, for example, if we earn 5K a month, and then our salary increased by, for example, 10% every year, and this has to be, of course, the rate of increase has to be higher than the 5%, because otherwise we cannot afford to buy a house forever, right? So now this is another sequence. It's also increasing in value. 5K 1 plus 10% for the first year, and 1 plus 10% for the second year, right, and etc. So, so this is another sequence. Now, okay, so now the question is, with these two sequences, when can we afford to buy a house, right? Now, when it comes to buying a house, then that means that we need to have enough money to the money saved in the bank. It needs to be more than the housing price as a future time point, right? So what does it mean by money saving in bank? So for example, when I earn this amount, I could be saving about 20% every year for my salary, and then saving in the bank. So every year I save in the bank, and then this savings also increase. So this is again another series. And if I were to plot it on the graph, this is time. This is my amounts saved in the bank. Then each year, the amounts will be growing, right? So it's going to be following the geometric sequence. And then, so if I'm at this time point, maybe 10 years from now on, this is year 0. So the total money I save in the bank would be the area under the curve. Right? So the area under the curve, because I'm just adding up all the previous savings in the bank to say I have this amount of money at the future time point. So this amount needs to be, if I were to draw another graph which is on the same coordinate system, this is the housing price. Housing price needs to be higher than the housing price at that time point. So, so what does it mean? We are comparing the integral, right? So the area under the curve to a particular point of housing price, and in hope that, for example, at the 10th year, our total amounts in the bank will be enough to buy a house. So, let's extract from this exact terms to some absolute, some abstract formula. So the formula to calculate the amounts or the price of housing price in the future year would be the total amounts for the principal or the initial housing price, right? P, and then multiply 1 plus the rate of increase, for example, in this case, 5%. Let me just express it's R, right? So this is my rate of increase, and then the rate, and then to the power of T. So T is the number of years, right? So we do this increment annually. And then so this is the this gives us the price at each time point in the future. So so the question is how do we calculate the area under the curve? So this is a sum of geometric sequence, right? This is a sum of geometric sequence, and we learned that there's actually a closed form formula for this. So let me just express the bottom as R, so that it's actually it represents the rate of increase, right? So it's the same thing. So now in this case, it can be 1.05 for R. So R represents based on the total amounts, how much additional in total, right, I get. Now, okay, so let's do a bit of search. So I'm gonna search for the sum of geometric sequence, which I have already, and it's taking this this form, right? So so this is the formula we have. It means that A is our total amounts, initial amounts, and then 1 minus Rn to the power of n, and 1 minus R. So we can also express this now these amounts. Every under the curve can be expressed as P, total amounts, multiply. I'm gonna move this in front, R to the power of, so this next is gonna be T. So we're doing the summation for up to T years minus 1 divided by R minus 1, right? So R minus 1. So this gives us the total amounts the money we receive in the bank after T years, right? So we're going to combine these two. So of course we can do this analytically to say at which point for a specific value of P and R, right? The principal amounts and the interest rate. How big should PT be so that we can afford to buy a house? So instead of calculating this analytically, I'm going to show you how to do this in Python, because this gives us the framework to do some analysis for different configuration of parameters, and this can be very helpful tool for other similar analysis as well. Right. So let's first translate this to codes, and then we can have a good handle on this. All right. So I'm going to switch to my Jupyter Lab. So this is just a coding environment, right, which helps me to write codes. Okay. Now let's first define a few variables. So for example, I have initial property price, right, which gives me, for example, 1 million. So 1 million. So so if it's 1 million, then that means have 10 to the power of 6. So I can write what can write is 1 is 6. So this represents 10 to the power of 6, right? So let's just define some variables, because later for different scenarios we can just change parameters here instead of hard code it, right? So now my property growth rate, so it's also growing. It's following a geometric progression. For example, let me set it 0.05, because 5% is something that that's happening in our real life, because all the housing prices are increasing, and basically a lot of things are becoming more and more expensive. Right? So okay, so with these two, let me just run this, and you can see that I can actually start to calculate the amounts after T number of years, right? So if I say so let me see my current amounts, right, is the amounts that I will get after T number of years. So so I can just write this is initial amounts or the principal, and then I'm gonna multiply by 1 plus this one, the rate. So this is the base, right? So to the power of the T. Now, for example, after 2 years, this amount I would get, and I would print the amount out. Right. So it could maybe about this amounts additional, right? So this is after the 5% increment for 2 years. So that means that I can change this variable, I change the number of years, and then gets the total amounts to get the current amounts as the future T years, right? So now this is where things become can be sort of abstracted away by writing it as a function. So what do I mean by writing a function? So let's can define a function that can help us to calculate the current amounts, right, after geometric progression. So it's going to take a few parameters. So we can pass it the initial amounts, right? Initial amounts. So these are called the input parameters, which is going to be accepted by the codes, by the function. And we have the growth rates, right? So which are already defined. Then the t number of years, t years in the future. So how to calculate the amount? So I can say current amount. Actually, I can just paste it here. So copy, paste it. Now this is my initial amount because I'm following the logic in this function. So this is my input. This is my growth rate, and I'm taking it to the power of t. So it's gonna be t. And lastly, I only need to return this value as the return of the function, right? So now instead of writing this, I can just say call the function, and then pass in the corresponding variables. So I can pass in, say, initial amount is my this one. So this is my initial amount, and then this is my public growth rate. So that is my t number of years for example, 2 years, and then it's going to be giving us the same amount, right? Same amount. So I can just say, oh, I want to try something else. Maybe it's going to be 2 million, and then it's going to be growing 10% a year. So it's going to be 0.1, and then this gives us the future amounts after 2 years, following a 10% increment annually. So again, this becomes flexible, right? Because we can just call this function, passing different parameters, and then it will give us the value, right? Okay, so we can also start to plot it, right? In terms of the future progression. How do we do it? We can say, for example, so let's import some packages. So import numpy as np, and then import something else just to help us plot the graph. Naturally, this can be a widely used package for plotting. Then import the pyplot as plt, just a short name, right? So this is imports the package. Now let me use something. So I want to evaluate for different values of t. For example, it could be 1 all the way up to 30, right? For the future 30 years, how does my housing price look like, right? So that's the question I want to ask. So the way to calculate it is can be something like this. So I want to calculate this. Again, still, let me just copy this. So copy this one. But this is the amount I want to calculate, right? Still the same amount, but I'm going to change the years. So this is the only thing I'm going to change. And then I want to say evaluate t years from, for example, 0 to 30, right? So how do I do? So the one way to do is to use a list comprehension or for loop. So it works as a similar as a for loop. So I can say for each year t in the range of t number of years, for example, 30, right, for 30 years. Now this range essentially gives us different values of t. Let me just show it to you. So 30, what does it give us? It gives us a range. Now, what is the range? What's inside the range? So I'm going to extract the value inside. So it basically gives us the value from 0 to all the way to 29. Okay, so that's the side notes. Let me cut it out, and then so t is going to take the value of from 0 to 29, and for each t, I'm going to pass it to the calculation here. So initial amounts, again, take it as the initial property price, right? Copy and paste. And then I have the growth rate, which is the property growth rate. Property growth rate. So basically for each value of t, I'm going to calculate this, and the results is going to be wrapped as a list. So it's just a data type. So this is how I can get all the different property prices for the future years. And I can say this is my yearly property price. Pass it to this variable. And then I'm going to return it to see what it looks like. So copy, paste. Right. So basically it means that for each values, for each year in the next years, I'm going to calculate the amounts, the price of the house, right? So calculate, and this gives me a evolution of the geometric series, right? So this is evolution, and of course I want to plot it on the graph so that is more intuitive. So this is where I can call the plot function, and just plot it. So have a graph here. So this is following geometric progression. Still looks a bit linear because the rate is only 5%, and we're only got 30 steps ahead, right? So it's still not so growing very fast. But now let's look at another scenario, which is that we want to look at the salary. So let me do the same thing. So let's copy paste. So initial salary is gonna be, for example, if we save 15K, right, 1500. So this is totally something achievable because if we say, for example, earn 5,000 a month, and then say save, for example, 1,000 in a bank, right? And then so this is every month, and so in a year we save about 12,000, or in this case, we can make it 15,000 per year. So this is the initial savings, right? Initial savings per year. And then our salary is also growing. So so the savings growth rate is this. Savings growth rate is about 10%. So it has to be growing faster than the housing price. Otherwise, you can never expect to buy a house, right? So that's our parameters, and we are also going to do the same thing, right? So this is where we can just copy and paste. However, note that so this is we're going to calculate the total amounts, no, cumulative capital amounts, because this is where we are calculating area under the curve, right? So remember the slides. This is a formula we want to encode in the codes, right? So this is like, so R is our 1 plus interest rate. So let me just clear it out. So first we have the top initial amount. So we have the initial amount, and then we have this portion. So first we need to raise R to the power of t. So raise to the power of t is what we have here, and then we're going to minus 1. So this is where we will do the minus 1. Minus 1, but it's actually separate from the multiplication. So let me add parentheses, right? So separate out, and then divided by this R plus 1, R minus 1. So R minus 1 is just my growth rate, right? Because this is R, right? 1 plus which is R, and then minus 1 is just the growth rate. So this is the growth rate. Then I'm going to write as a cumulative amounts. This is our calculation now. And then we can just return it. So we can do an evaluation and then see how it works. So we can say evaluate is a function for these two parameters, right? So for the initial savings per year and its growth rate, which is 10%. And then say after 10 years, gives me this amount, right? So this is another geometric sequence, and we're calculating the cumulative amounts. And similarly, we can say how fast it's growing, right? So it's another sequence, and it's also growing. So let's say, so we are doing nothing more than just repeating the same operation. The only thing that's different is that we're calculating the cumulative amounts. So I'm switching this function to the cumulative amount function, and this is going to be my t, right? And then this is my yearly total savings. So calculating total savings. Here, total savings, and then this is another sequence, right? So it's slightly the curvature is slightly higher because the rate of change, rate of increase is slightly higher, right? Okay, so now let's come to the last portion, which is to sort of put things together, right? So by putting things together, what that means that with all the different configurations, so this is the one configuration, this is two configuration, and let's so we can try to plot these two plots together to say when do they intersect with each other, right? Now, if there's an intersection, then means that now we can have to buy a house. So so for convenience, I'm just going to copy these parameters below so that it's easier to manipulate, and then copy these parameters below. Okay, and we're going to again do the same thing to calculate these two amounts. So this is my first amount to copy, and this is here, and this is my other amounts. Okay, other amounts, right? So I'm going to copy it, paste it here. But pay attention that we're doing 30. So we're not just encode it as another parameters to say t number of years, right? So, and it's more flexible. We do not need to change it twice. So let's say t years equals to 30, right? So it's actually more flexible. So once we set the parameters, we calculate the amounts of interest, and then we can finally plot it. So how do we plot the so we can just plot two things right together in one shot. Now the other thing I'm going to do is to get the x-axis years from the number of years we have. So I'm going to say range t years, and then so what it means that's I have 30 years. I'm just converting it to a numbers 0 to 29, right? So this is gonna be my x-axis. What is my y-axis? So y-axis is gonna be two plots, right? So it's gonna be first plot is gonna be this one. So we're going to copy paste. So this is the first one. And this is my y-axis, right? So this is my x-axis. So because I'm plotting multiple things together, it's good to specify this is x-axis, this is y-axis, and then the corresponding label for this series is this is my yearly property price, right? And I can do the same thing for the second plot. For one more. Okay, so this is my first sequence, and I'm going to plot the second sequence, which is the yearly total savings, which I already calculated, and then put it here. So cumulative savings, right? Savings. Now, not just show you, so, but I want to show the legend as well to say which one is which, right? So when you to differentiate these two sequence. So, okay, now this is where we have everything. You can just run it, and then it took us two plots together in one shot. But you see that we are still far from enough, right? Maybe it takes about 60 years. I don't know, just to try it out. So okay, so it's indeed takes about 40 years. So we need to almost work for the entire lifetime to be able to buy a house, right? So this is clearly too long for us to buy a house. And let's so this is where we can play around. So let's say our initial property price is 50 million. Let's say maybe times 0.5. Say how long does it take? So it's now becoming about 30 years or 29, the intersection. We can zoom in by reducing the number of years to maybe 30, and then run it. So, okay, so now the interaction is about 28 years. Okay, so this can change in multiple ways. For example, if we say I want to take the bank loan, the mortgage, right? So that means I can pay for example, 20% down payment only, and then the rest just serve the loan, right? So how does it work? How does it look like? So let's run it. And then suddenly it takes about maybe 7 years, right? So still manageable. So this is where things become a bit more manageable. And if the housing price further decreases, right? So if say 30%, say we want to buy HDB flat, then how does it look like? So let me just run it. Now suddenly it's becoming about 4 years, right? In 4 years, we can afford to buy a house, afford to buy HDB flat. And that's sort of what's happening in Singapore now. So fresh graduates, when they work for a few years, they can afford to buy a house because of the mechanism, right, placed here in Singapore, and this may not be necessarily the same in other countries. All right, so that's through this exercise, I want to just highlight that first is to see that our understanding of geometric sequences, right? So both are increasing, but one is increasing. So different sequences are increasing at different rates. So if we take it long enough, then the distance is going to be higher and higher, right? And secondly, just want to show you how to sort of put what we have in mathematics in the formula expression in code, so that we can start to do some analysis and then do this in a sort of more configurable manner. Right? Okay, so that's it for this additional topic, and thanks for watching.